Okay, so this lesson in calculus will lead into the definite integral, but it starts by what you also usually start with is looking at what's called the method of exhaustion. So if you're looking at the method of exhaustion in calculus, what you're doing is looking at a curve or a line, and you use shapes that you know the area of to find shapes that you don't know the area of. So this is a really simplified version of this, and this is straight from the textbook of chapter 10. And if you wanted to find the region under the curve that's graphed here of x plus 1 from 0 to 6. So if I wanted this region here, I can look and see that this is actually making somewhat of a trapezoid shape. So first part here is find the area using the trapezoid formula. So the area of the trapezoid formula is the altitude of the trapezoid. So our altitude in this case, we're going to view it as if we flip this around. So it's going to be from 0 to 6. So the altitude is 6. And then you take the length of base 1. So I could say it's this part here, and that's going to be 1. And you add the length of base 2, which is 7, and then you divide the whole thing by 2. So we'll find out that the area is 24. And what we want to also relate that to is how using rectangles could get us near that same number, and why we need another method. So this next part is saying use your subintervals of rectangles to figure this out. So for instance, if I looked at area of shape 1, your base is going to be 1, but my rectangle I'm going to make here goes like this, so my height is 2. So my first shape is going to be 1 times 2 divided, and that will equal 2. And then I'm going to move on. So the area of my next rectangle going this way is going to be 1 times 3, and that's just 3. And I'm going to keep going until I get to the very end, which would be 1 times 7. So I would see that for my next block, it's going to be 4. And then I would have, if I keep doing the math, 5, 6, and 7. And then when I add up all of my rectangles, I get a total of 27. So we're noticing that it's a bit larger, and hopefully we can realize it's because we're adding a little bit every single time we do this. So we're not quite as accurate as we could be. So the next part is, how can we make it more accurate? Well, instead of dividing by 6 equal intervals, we could make these intervals even smaller and smaller and smaller. So whatever ends up being kind of over on the top gets smaller and smaller and smaller, and your number should get closer to 24. Now, this isn't ideal. This takes a lot of time. So there is another way, and this is a connection to the definite integral. So you might see this a couple ways. The way we're going to focus on is here. If you have numbers from your integral, so that's in the last one would be 0 and 6, and you take the antiderivative, then if you plug in those values of the top of that limit minus the bottom, you'll have your answer. So if we show using the formula, the first one, y equals x plus 1 from 0 to 6, we're looking for your interval from 0 to 6 of x plus 1, and we're going to take the antiderivative of this. So doing that, we would get x squared divided by 2 plus x, and we're going to calculate from 0 to 6. So let's plug in that top limit, which is 6. So 6 squared divided by 2 plus 6. And then we're going to subtract, plugging in 0, 0 squared divided by 2 plus 0. Hopefully we can see that this just equals 0, but just showing the work. And then you plug it all in and you get 24. So it is the same answer as finding the area of the trapezoid. It's just a lot quicker. So if we wanted to try a few more examples using the antiderivative, the first one I'm taking a look at here is from -2. Sorry, my pen here is not working. So we'll have from -2 to 3, and we have the derivative, or the equation, 1 minus 4x dx. So if we wanted to figure out the definite integral of what we're seeing here, then we want to take that antiderivative. So we'll have x minus, it would be 4x to the power of 2 divided by 2, which ends up being 2x squared. And we're calculating from 3 to -2. So we can go ahead and plug in those values. So the first one will be 3 minus 2 times 3 squared. Get that answer, and then plug in the lower limit. So you'll have -2 minus 2 times negative 2 squared. Plug this all into your calculator, and we should see our answer here is negative 5. So hopefully this feels okay, but we could try one more still. And these are from your textbook, page 500 of the Intro to Calculus textbook. So this one's looking to go from 0 to 1 of the equation x cubed and then dx. So taking that antiderivative, you would have x to the power of 4 divided by 4. And again, we're going from 0 to 1. So we'll plug in the 1. You'd have 1 to the power of 4 divided by 4. And then subtract 0 to the power of 4 divided by 4. Of course, it's just a 0, and this would just be 1 over 4. So hopefully you're finding this nice and easy, just plugging in some values, pretty simple. I hope this was helpful. If you did, please subscribe. If there's any other videos I could do for you, just let me know in the comments. And if you're in chemistry, check out my channel for videos and links to my website with a bunch of videos and information there. As always, thank you for watching.